All right, here we have the pH and conductivity sap meters. These meters are brilliant for the job because they will operate on approximately 3 drops of plant sap. And you can do wet soil with them. That's a little bit more involved, but you can do water with them, you can do soil water solution, and you can do plant sap. And it's a plant sap in particular where these are valuable, because you do the pH in your soil water solution and your plant sap and see what it's doing, and then you do the conductivity, because while conductivity, or EC as a lot of people call it, in the rank and file industry, they use high EC levels. They say you got a salinity problem, but the thing is, at low levels, the late Kerry Reams, for instance, used EC as a measure of the flow of energy, both in the soil and in the plant sap. And if we got down to, say, we got down to 50 microsiemens, we wouldn't waste time planting that soil. It's a waste of time because there is not enough energy and not enough push there. And that, so EC is a very valid and a very useful tool to use along with the pH. And that, so yeah, they're very good. They're simple, as I said, and what we do is we take our garlic press and we squeeze about 2 or 3 drops of plant sap into the little cup on that meter. We close the flaps on our meters, we turn them on, and we get our readings. And that's about all there is to it, apart from cleaning it off. You just clean them off, rinse them off with a bit of water and detergent and a bit of clean water behind them, and then you just dab them dry with a tissue. You never ever wipe those sensors out because you're likely to break the membrane on the bottom of them. So yeah, very, very good and very useful little tools, those. And between the bricks, the penetrometer and those two, I truly believe personally that an awful lot can be done if we learn to understand the interaction of our elements along with it. With the pH meter, preferably we would like to see our pH running about 6.3, 6.4 up to about 6.8. That seems to be a pretty good range where almost all your elements are all pretty much in balance and pretty much available. There are some crops though, some people grow that they say, oh, they'll grow, well, you need an acid pH soil. But then if you listen to my good friend Dr. Arden Anderson, Arden has always said they've seen blueberries doing extremely well in about a 6.4 pH soil on that. And that's simply because the balance and interaction of all the nutrients was there. With our conductivity, we like to see it running, preferably your soil, if your planting time needs to run at a minimum of 100 microsiemens, that is. There's several different figures for talking about this. There's microsiemens and decisiemens and millisiemens and that, but a microsiemen and a decisiemen, as I understand, it's about the same. And then 1 millisiemen is equal to 1,000 microsiemens, so that one's simple. But yeah, about 100, minimum of 100, preferably 200, and say it was a wheat crop, by the time it's coming into head, better it's running 500 or 600 or maybe even a little more. But if we got to 800 in the soil on a soil reading, or 8,000, we change from hundreds to thousands when we go into plant sap in terms of talk. But if we get to 800 in the soil or 800 in plant sap, and indeed I learnt this bit from the late Dr. Dan Scow, he says if you get to 800 you start worrying about where the excess is coming from. So, and that sometimes means you've got to get a proper analysis done so you can see what element or elements may be pushing it up there.